All right, so for section 8.3, day 2, you're going to do 3 different things. First thing that you're going to do is you're going to write a rule. Okay, and the rule again is just the equation. So you're trying to figure out what's the equation for the geometric sequence. Okay, so that's the first thing that you're going to do. Second thing that you're going to do is you're going to find the sum. And like you've done in the other 2 sections, you're just trying to figure out what's the total from those, and we do have a formula for that. And the third thing that we're going to do is a word problem. Okay, and I got a formula that you're going to use in this video with the problem that's from your assignment. Okay, it's how to calculate a monthly payment on a loan. So it could be pretty important for some of you that are possibly getting cars soon. So anyway, here it goes. So the first example, what I'm going to do is I'm going to give you something like this. It's going to say a sub 2 equals 12 and a sub 5 equals negative 768. And your job is to write the rule. Okay, so that's what they're going to ask you to do, is write the rule for this. Now, if you recall from day 1, a sub n equals a1 r n minus 1 is the generic formula for geometric sequences. And so what you're going to do is these parts right here, this is an n and this is an a sub n. This is an n and this is an a sub n. And so I'm going to write 2 different equations. So 12 equals a1 r to the 2 minus 1, and negative 768 equals a1 r to the 5 minus 1. So all I did was I inserted those numbers into the generic formula. Now, what I'm going to do next is I'm going to clean up these exponents just a little bit. So I have 12 equals a1 r, and negative 768 equals a1 r to the 4th. Okay. Now, the next step is important because what you want to do is you want to solve your equation for a1. And there's a reason for that, and I'll explain while we're going. But the one thing that you need to do is you need to solve the equation that has the smaller r. So I'll circle it in blue so that you see it. You have an r to the 1st here, and you have an r to the 4th. So it's this equation that you want to use in order to solve for a1. Okay, and the reason why we're doing that is because in the next step, we're going to use substitution and plug that in. And we want our r to have exponents where when you subtract them, that the r will remain on the top of the fraction rather than the bottom. It's a little bit easier that way. So again, what you're going to do is you're going to solve for a1, which in order to do that, to get rid of times, you divide both sides by r. So you have 12 divided by r equals a1. And then I'm going to take that and I'm going to insert that into the other equation for that letter. So I end up with negative 768 equals 12 divided by r times r to the 4th. And again, the reason why I'm doing it this way is because when I cancel these r's, this r and this r right here, I'll have r on the top rather than r on the bottom of the fraction. And that's the important part, is to keep it up at the top, a little bit easier that way. So I end up with negative 768, 12, and then for the r's, this is like saying r to the 4th over 1 and r to the 1st on the bottom. And when you use that quotient rule from exponents, if you have more on the top versus on the bottom, you subtract the exponents, and 4 minus 1 would be 3. Now, from here, what you want to do is you want to then end up solving for r. So divide everything by 12. So end up with r to the 3rd equals negative 64. And then to get rid of cube, you cube root it. And remember, you can cube root negatives, so therefore when you're looking at a cube root and it's a negative, your answer is going to be negative. And so when you take the answer, you should have a negative because there was a negative underneath the cube root. And then the cube root of 64, you could use your calculator to do that. If you're using a TI, you'd hit math, and I think it's option 4, and then you could type in negative 64, and then it would give you the answer. If it didn't work out perfectly, then you'd just reduce that cube root as best as possible. But it does come out to be negative 4 for the r. Now, once you have r, again, you're going to use substitution, and you're going to plug it back in to find a1. So 12 divided by negative 4 is negative 3 equals a1. So what you've done is you've gotten all the components to writing a rule. All right, and so over here in red, this again was the formula for writing a rule. I don't know how I made that dot, but that was pretty cool. And now what you have to do next is you just have to insert the pieces that you found. It's kind of like putting a puzzle together. So a1 is equal to negative 3. I like to put my r in parentheses. It's not necessary, but what you want to do is you want to make sure you have at least a time sign in between them, because if you don't, it's going to look like negative 3, negative 4, like a subtraction problem, rather than a times situation. And minus 1, I shouldn't have wrote it so close. I'll write it down here. I got my room here. Negative 3, negative 4, and minus 1. And that's your rule. So that's how you do the first few problems from this assignment. Whether it's in where they give you two things like that, where it says like A2 is 12 and A5 is this, or if they give you a picture where they give you some a bunch of dots. Use the dots in order to come up with two ordered pairs. This would be like, this is the second one and it was 12. This would be the fifth term is negative 768. Or if they give you a table of values, again, just pick two, and it would be like, this is the second term and it's 12. This is the fifth term and it's negative 768. And that should help with doing problems 33, 36, 39, 41, 43, and 45. That's how they're all done, is just this on this screen. Okay? Then the next thing that you're going to do, the second thing, is going to be you're going to find the sum. Okay, and that was the second thing that we have. In order to find the sum of a geometric series, and I believe all the ones that we give you are finite. And if you remember what finite means, is that finite means that it stops. Okay, you're not going to go on forever. We're going to do infinite later. Okay, so the sum of a finite geometric series is done by taking S of n equals a1, 1 minus r to the n over 1 minus r. And just to point out what everything is, this would be the first term. So that's the first term in your sequence. R stands for the rate or ratio. Okay, so the ratio is in two different spots, that common ratio. Remember from day one, common ratio would be things like if you're multiplying by 2 to everything, or if you're multiplying by a fourth to everything. Those are your common ratios. And the n stands for how many terms. Okay, so that's what the n stands for, is how many terms are you adding. So if you're adding 5 terms together, then your answer would be 5 for that part. Okay? So this is the formula that we're going to use. A lot of this is going to be plug it in your calculator and see what comes out. If it ends up being decimals, we can frac things on your calculator, so that way it'll convert it to a fraction for you. But we can use our calculators for a lot of these problems. Some of you I know with the summation stuff in some of the conversations I've had with you, if it has 10 terms, some of you just are fine or like, I'm going to find all 10 and add them all together. And you know what? That's not a bad way to do it. It is a method. It's just this formula will make it a little bit easier. It's one thing to do instead of 10 things to do. So that's why I think this will be a little bit easier for you. Okay, so let me show you how it works. So if I give you the summation symbol with a 10 on the top, and then k equals 1 on the bottom. So first thing I'm going to look at, without even looking at the formula, is this. I have a 1 down here and I have a 10 up here. That's going to tell me, if I go from 1 to 10, how many numbers am I actually going to add together? Well, if I start with the first term, second term, fourth, fifth, all the way up to 10 terms, I'm going to sum 10 things, which means the n in that formula was 10. Then the next part will give you something like that. So it'll give you the equation for that. Now, for what some people like to do is, some people like to do the first term and then maybe even the second term to find the common ratio and the first term. But if you recall, one of the things with this, and I'll put this in blue so it's a little bit, stands out a little bit. If you look at the formula itself, sometimes these are in the format of the geometric sequence. So for this particular thing, you could just pull out a1 is equal to 4 and the common ratio is 3, just by looking at it. But if you can't see that, what I would want you to do is I'd want you to put in the number 1 first and see what comes out. So first of all, I'll put the exponent. 1 minus 1 is 0. Then the most important thing you can do for this, and this is what a lot of people get it wrong, is they do 4 times 3 first and then they do the exponent. But if you remember the order of operations, exponents need to come first. So 3 to the 0 is 1, and then 4 times 1 would be 4. So there's your first term. Now to figure out a ratio, you might want to have the second term. Okay, so in order to get the second term, you'd put 2 in there. 4 times 3, 2 minus 1. 2 minus 1 is 1. 3 to the first power is 3. And 4 times 3 is 12. And then to find the ratio, you could take the second term divided by the first term, or in this case 12 divided by 4, which again is 3. So a couple different routes to take as far as getting the setup, as far as finding the A1 and the R. I showed you both just in case it wasn't in that form directly. It's not necessarily going to be that way in arithmetic ones, but it will be more in geometric ones. But now over here on the side in blue, now it's time to actually do the summing. So the first thing that we're going to do is we're going to sum the first 10 terms. And the reason why, again, we got 10 is because we're going from 1 to 10. So looking at the formula that I gave you on the previous slide, A1 is 4, 1 minus, and then the ratio is 3. And remember, we're doing 10 terms. 1 minus 3. Now, if you're not that comfortable with doing using your calculator, what I'm going to suggest that you do is a technique I like to refer to as chunking, which means I want you to do each part individually and then bring it all together. So for this particular thing, a 4 would go on the outside. And without the use of the calculator, I'm pretty sure I can do the bottom one without even looking. 1 minus 3 on the bottom would be negative 2. That's not that big a deal. The top, however, is the part where a lot of people end up messing that up. And what they do is you see 1 minus 3 to the 10th, and they forget. And what they do is they do 1 minus 3 first, you get negative 2, and then take negative 2 to the 10th power, which is not the way to do that. What you'd want to do in your calculator is you could physically type 1 minus 3 caret 10, and it will give you negative 500 or 59,048. Like, it'll give you that number, and it's a pretty big number, but that's because you're also doing 3 to the 10th power. That's a big thing. Okay, so be careful with that. So then what you want to do, and if you're still doing the order of operations, you take that number and divide it by negative 2. So you end up with 4 times 29,524, and then you multiply it by 4. And you end up with 118,096. And that is your overall answer. Now, if you think back to what I said at the beginning of this segment, you could find all 10 terms and add them together. And if you did that, it would give you 118,096. You'd have some big numbers. And I know I've had some students in the past that have said that that's how they want to do it. And when they do it that way, they always think, well, I must have did it wrong because the numbers are too big. With geometric series, they are going to be big answers a lot of times because remember, you're multiplying to get that next number. And so that's where your numbers are going to grow because it is being multiplied. Okay? So that's how you'd find the sum. That would take you through problems 48 and 51. Then the last thing that I'm going to show you is this is the formula that you're going to need for number 57, okay, in order to calculate the monthly payment. M is going to stand for the monthly payment. So that would be if you ever ask your parents or if you yourself have a car and say, you know what, my monthly payment for my car is $398.79. That would be what the M is. Okay, so this is a lot of times how, or this is exactly how the bank calculates what your monthly payment is going to be on loans like cars, boats, houses, things like that. Okay, then L is going to be on the top. What L stands for is the loan amount. Okay, and I'm going to put that in blue so that you know that that's the loan amount. So for instance, if you buy a car that's $20,000, 20,000 will go in for that L. Okay? Oh, and I better put monthly payment over here. Okay? Then the rest of the formula has, and you'll notice this one because obviously you've seen this a time or two, that summation symbol there. And then on the bottom, it's going to say K equals 1 to T. And T stands for time. And a lot of times what we do in terms of time is for loans. Loans are always listed out monthly. And what they mean by that is if you were to go take out a car loan, they wouldn't say for 5 years, it would say for 60 months. Or if you were to take it out for 6 years, it'd be 72 months and so on. So a lot of times when you look up stuff like that, it's going to give you it in terms of months rather than in terms of years. Then the equation is, I got that extra mark in there I got to get rid of. 1 over 1 plus... Now, your book uses I. I like to use R for the interest rate, but your book uses I, so we're going to use I there as well. Okay? And K just stands for how many that you're doing. Now, the thing with I is important because I is the monthly interest rate. So on your problems, it might say something like you get an annual interest rate of 6%. But that's not 6% each month. That's 6% for the entire year. So when you're looking at problems like that, you have to do something a little bit different. If it says the annual interest rate, let's say it's 6%, then what you're going to do is to find I, you're going to take 0.06 and divide it by 12. And that number right here is what's going to go in for that part there. Okay? Then from here, the rest of it, I'll just read you a problem and then everything will fall into its place. So for this particular thing, it's going to say that calculate the monthly payment on a 5-year loan. Okay, so I guess when they do say 5 years, that would equal to 60 months. And the reason why it's 60 months is because there's 12 months in a year. 5 times 12 is 60. For a $20,000 loan with an annual interest rate of 6%. So that's what they're going to give you. Now, what you have to do is you just have to insert the pieces into your formula and then from here calculate what the monthly payment was going to be. So the first part is the loan amount. That's $20,000. That's how much you're borrowing from the bank or credit union. And then you have the summation of, and then on the bottom you have your variable, whichever variable you like to use. Your book uses K and I a lot. And then this would be up here 60 because it's 60 months for the whole length of that loan. And then the rest of this part on the bottom, 1 plus, I messed that up. I wrote the wrong thing. I was thinking of a different formula. 1 over 1 plus 0.06 divided by 12. And then that would be, and then the rest of that would be a K, so that you know that it would be there. So in order to do this problem then, because this bottom has a summation symbol, what you'd end up doing is you'd end up doing, you'd end up using that sum formula from the previous problem. Find your A1, find your R, and then from there, you can, once you get that summation, because I don't think you want to do all 60 numbers. So for this one, you'd have to do, if you wanted to find it out the old-fashioned way, you could do 1, put in 1, get an answer, put in 2, get an answer, put in 3, get an answer, 4, answer, 5, answer, and so on, and that would up to 60, and that would take you a long time. And then you'd have to add them all. So use the formula, it will go a little bit faster for you. And then once you get that number, divide it by 20, and away you go. If you actually take a look at your book on page 429, and if you're using the online stuff, it's the dynamic book. Go ahead and look on page 429, and they actually give you a little thing on the side of the process for example 6, where it gives you how to type it into your TI calculators. So it might make it a little bit easier for you. Okay, so on that note, that's 8-3 day 2. Thanks. Bye.